Well, very good morning to every one of you. So today we are going to continue with the second part of our video lesson today. Where today we are going to continue with the second type of the chemical bond, which is we are going to talk about covalent bond. Okay, so without further ado, let's have a look at the content of the lesson today. So the objective of our lesson today is include at the end of the lesson, you should be able to draw the Lewis structure of the covalent bond molecule, octet rules as exemplified by NH3, CCl4, H2O, CO2, and 2O4, and exception of the rules as exemplified by BF3, NO, NO2, PCl5, and SF6. You're also going to draw the Lewis structure of ions exemplified by SO2, CO2, 3,2 minus, NO3 minus, and Cl minus, including the transformal charge. And you are going to explain the existence of coordinate bond or dative bond as exemplified by HCO plus and H4 plus, Al2, Cl6, and also FeCl6, 3 minus. Right, so let's have a look at the content, shall we? Okay, so Gilbert Lewis suggested that the chemical bond exists in the hydrogen gas occur by sharing the electrons between the two hydrogen atoms. So with hydrogen, which has the valence electron of 1s1 here. So in order to achieve duplet arrangement, so each atom of the hydrogen needs to accept or donate electrons. So since both of them do not want to lose electrons either, so they think of the idea of sharing the electrons in between the two hydrogen. And this sharing of the bonds is also known as a covalent bond. Okay, and the electron pair that is shared by between the two atoms is also known as a bond pair electrons. Okay, so we can use a Lewis structure to represent the covalent bonding in which the electrons are shared either as a line or as a pair of a dot and dot between the two atoms, and the lone pair electrons are shared as the pair of the dots on individual atoms in here. So, for example, if you have two fluorine atoms, so both of them has the valence electron of 2s2, 2p5, so both of them lack of one electron to achieve octet. So therefore, each of these fluorine atoms will share the electrons to form a single covalent bond in between the two fluorine atoms in here. So this pair of electrons that is formed when two electrons are shared by each of the respective atom is also known as the bond pair electrons, whereas the one that is unshared electron pair, so we call it as a lone pair electrons here. Okay. So it is important for you to understand the terms in the beginning of the lessons in here because later you keep on hearing we use a lot of these terms here. Okay, so after sharing the electron, now both of the fluorine here has how many electron? We have 2, 4, 6, 8. So therefore octet arrangement. This fluorine also have 2, 4, 6, 8. Therefore achieve the octet arrangement here. Okay. Okay, so this is how we are going to describe for a single covalent bond. So we're going to have a look at oxygen, okay? So when oxygen with the valence electron of 1s2, 2s2, 2p4 respectively in here. So both oxygen atom needs to share two electrons in order to achieve octet configurations. So both of the atoms in here share two of their electrons to form what we so-called as a double bond here. Okay, so when two electrons by each atom share to form two bonds like this, we call it as a double bond. Okay, so after you form a double bond, you have the valence electron of 2s2, 2p6 for both oxygen atoms. And last but not least, we have the examples of triple bond, which is exemplified by the nitrogens in here, where nitrogen has the valence electron of 2s2, 2p3 here. Okay, so each of the nitrogen share three of its electrons in order to help each of them to achieve octet configuration. So therefore, you share three of the electrons from each atom to form what we so-called as a triple bond in here. So after you form the triple bond, so both of them has 1s2, 2s2, 2p6 configurations, which is 8 octet arrangement for both of the atoms in here. So this is how a covalent bond can be formed. It can form either a single bond, double bond, or triple bonds. Okay. Okay, so these are elements of how they exist naturally inside atoms. So we are going to understand more about how to draw the how is covalent bond is formed in between the uh, elements inside the periodic tables here. Okay, so in terms of compound, okay, so in terms of compound, so these are the step-by-step uh, of how to draw the very structure of a covalent compound. Are you ready? So first step is calculate the total number of the valence electron from all the atoms in a molecule in here. So we have group 1, you have 1 valence, group 2, 2 valence, group 3, 13, 3 valence, group 14, 4 valence, group 15, 5 valence, group 16, 6 valence, group 17, 7 valence, and group 18, 8 valence electron. So you sum up the total mole of electron, and if let's say if it is a ion, so for cation, your total electron is equals to the valence electron minus the charge, because to form cation, you donate electron. When you donate electron, you have lesser electron. And conversely, if you have an anion, so the total electron is equals to the total valence electron plus the charge of the anion, because you accepted electrons. So you are going to get more electrons here. Okay. Okay, then number 2, place a covalent bond between center atom to the surrounding atom. So usually the one with the monoatom in the molecule is the center atom. So for each bond that you draw, you minus 2 electrons from the step 1 here. Okay, then number 3, you make the surround atom to become octet, where each surround atom is placed with 6 electrons in here, or 3 lone pair electrons. So in here, since you have 6 electrons, so you minus 6 electron out from the step 2 in here. Okay, so except for hydrogen, hydrogen we need 2. And then if let's say after the step 3, you still have remaining electron. So you have step 4a. Place all remaining electron in step 3 of the center atom as a lone pair electron. Or there is an alternative step here. If let's say you have no more electrons left, okay, so you form multiple bond from any surround atom to make sure that the center atom also achieve octet. Okay, so you have to make sure that there are no more electron remains at the end of your calculations. Okay, so if I just mention like this without any examples, you probably will not be understand. So let's use step by step of how we are going to draw the very structure, shall we? Okay, so let's start from the first example, water. So water, hydrogen 1s1, oxygen 2s2, 2p4. So hydrogen 1 valence, oxygen 6 valence. So total is 6 plus 1 times 2, which is equals to 8. So you put 2 bonds in between the oxygen to hydrogen, so minus 4 electron. So step 3, because hydrogen is duplet, so you do not need step 3. So for 4, we use 4a lah. So since the valence electrons in here, you have 4 electrons. So you put as 2 lone pair electrons at the center. So no more electron in the middle. So that is how you're going to draw for water. So for carbon dioxide, yes, 2s2 to p2, so oxygen is 2s2 to p4. So total valence electron is 4 plus 2 times 6, which is equals to 16 electron. So in second step, you put 2 bonds in between C and O first. So since you have 2 covalent bonds, so you minus 4 electrons, therefore 12 electrons remain. And then step 3, place the surround atom with 6 electrons. So since you have 2 surround atoms, so 12 minus 2 times 16, so you have no more electron. So in order to help the carbon to achieve octet configuration, you use step 4b, where in the step 4b, you use any of the surrounding electron pair to form a multiple bond to the carbons in here. So in this case, because carbon need 2 more, so each of the oxygen contributed 2 electrons in here, so that you form CO2 here. Okay. Right, so that is for step carbon dioxide. Then we have the next example, which is ammonia. So hydrogen 1, nitrogen 5, so total 8 electron. So place 3 bonds, which is 8 minus 3 times 2. So since hydrogen is duplet, so you have no step 3. And then place the remaining as a lone pair electron in the nitrogen here. So that is how you're going to draw for ammonia. Okay, okay, more example coming up. Okay, so we have a tetrachloromethane. Okay, so carbon group 14, 4 valence electron, chlorine group 17, 7 valence electron. So total valence electron is 4 plus 7 times 4, you have 32. Step 2, draw 4 covalent bond in between carbon to the Cl. So carbon is the center at top here. So you have 32 minus 4 times 2, you have 24 electron left. So you put the surround to become of that. So 4 surround minus 6 electron, you have 24. So no more electrons. So that's why in step 3, since there are no more electrons, so you do not need step 4. So that is how you draw for CCl4. As for phosphorus tribromide, PBr3, phosphorus is group 15, 5 valence electron, bromine group 17, 7 valence electron. So total valence electron is 26. So you put 3 covalent bonds, so 26 minus 3 times 2, so you get 6 electrons, so you have 20 electrons remaining. Step 3 makes the surround become octet, so you have 20 minus 3 times 6, so therefore you have 18. So you have 2 more electrons left. So in step 4, you put at P as a lone pair electrons for the remaining 2 electrons. Okay. Right, and then we have sulfur dichloride, SF2. So sulfur group 16, 6 valence electron, fluorine group 17, 7 valence electrons, so total electrons 20. So you put 2 covalent bond in between S and F. So you have 20 minus 4 electron, you have 16 electron. Then you have step 3, you make the surround to become octet first. So 16 minus 2 times 6, you get 4. And then finally, you have put the 2 lone pair electrons in here. So you have the two SF4 looking like this, SF2, sorry, right? So that is how we are going to draw for sulfur dichloride here. Okay, so far all these examples are for neutral charge. Okay, so we are going to have the next example, which is molecular ions in here. So let's say in carbonate. So in carbonate, you have 2s2, 2p2. So oxygen is 2s2, 2p4. So 4 plus 3 times 6. So you have 22 electron. Now, because it's CO3 2 minus, that means 2 electron accepted. So you have 24 electron. So second step, put 3 covalent bond at the carbon to the oxygen. So you have 24 minus 3 times 2, you have 18 left. So put the surrounding to become octet. So you have 3 surrounding atoms. So 18 minus 3 times 6, you get 0. Yeah. Okay, so now in the step 3, so carbon not yet achieve octet because carbon only have 6. So you use any of the one pair electrons to put a double bond inside here. So you can form this carbonate ions here lah. Okay, so why is it that in the slide here I put a star? Because this is in the new syllabus, this way of drawing the carbonate is no longer accepted in Stpm. So later we will improvise the structure of the carbonate. Okay. Okay, next one is cyanide ion. So carbon is 4, nitrogen is 5, so total valence electron is 9, plus 1 electron accepted because of Cn minus. So you draw 1 covalent bond in between this one, so C to N. So you have 8 electron left. So make 1 surrounding atom to become octet. So you put at the nitrogen, let's say. So you put 3 bonds like this. Okay. Okay, and then the minus 8 minus 1 times 6, you have 2 valence electron. Then you put in step 4, you put the lone pair electrons in here. So you put the remaining 2 electrons at the carbon. Yes. So now carbon has 4. Can you imagine? Okay. Now carbon has 4. So now you use also step B. So you have to put 2 lone pair electrons in here in order to help carbon to achieve octet also in there. So therefore, you have 8. So this is how Cn minus looks like. Okay, so this is also star because this is not the final structure of the cyanide. So later we are going to have a look in details in here. Okay. Okay, so then the next one is nitrate ion. So nitrogen group 15, 5 valence electron, oxygen group 16, 6 valence electron. So total valence electron is 23 plus 1 electron accepted, therefore 24. So 3 bond, so 24 minus 3 times 2, you have 18 left. So we have 3 surround atom. So therefore 18 minus 3 times 6, we have 0. So put the NO double bond O using the oxygen to make it become octet. Okay, so this is how nitrate ion looks like. And of course, this is also not the final structure. So later we are going to learn more about this. And then finally for sulfate ion, from both sulfur and oxygen are from group 16. So total valence electron is 13 plus 2 electrons accepted, therefore 32. So if you have 4 bonds, so 32 minus 4 times 2, you have 24. Then you mix the surround to become octet already. Okay, so 24 minus 4 times 6, we have 0. So this is how after you use the 4-step, but this is not yet the final structure because we have other things that we also need to consider when drawing the covalent bond for this. Okay, so for this molecular ion that we witnessed just now from just now the carbonate, cyanide, and then now we have this nitrate and sulfate. You see that all of them we put star because uh, this is not the final form of that you need to know how to draw. Okay, so now we are going to learn about what is actually a formal charge in here. All right, are you ready? Okay, so what is actually a formal charge? A formal charge is defined as the charge that it would have if the bonding electrons were shared equally. Okay, so formal charge can be calculated by the formula. Formal charge is equals to number of valence electron minus of number of unshared electron plus half of the number of shared electrons in there. Therefore, the charge carries by the negative ions or electron accepted or the positive ion where you have electron donated should be allocated in which atoms can be tells by using this method. What does it mean? That means because you accept or donate electrons to form ion, isn't it? There must be one atom that will be responsible to hold the charge that is accepted or donated from that molecule. Okay, so we are about to find out how to calculate the formal charge in here. Okay, starting from carbonate. So carbonate, let's start to calculate the formal charge of the carbonate. Okay, so I use the purple color in here. So carbonate has number of valence electron is 4 minus number of unshared. Does carbon has unshared electron? No, that's why it's 0. And does carbon has how many shared electron? You have 2, 4, 6, 8. So 8. So you use half of it. So 4 minus 0 plus 4, so you get 0. So formal charge of the carbon in here is 0. Okay, then let's have a look at the double bond O in here. Okay, so double bond O and single bond O have different formal charge. Okay, let's have a look at double bond O first in here. Okay, so you have 6 valence electrons minus of how many unshared electrons? So in here you have 4 plus how many bonded electron? You have 4 also, but you have to half it. So 4 plus half times 4, you have 6. So 6 minus 6 will get you 0. So oxygen double bond O have the formal charge equals to 0. As for O single bond, okay, so you have valence electron 6 minus the number of unshared electrons in here. So you have 2, 4, 6 in here. So therefore 6, okay. So plus 1 of the bond share electron. So 2 electrons in here. So this is not 1, sorry, typing error. It's supposed to be 2. Okay. So half times 2, you get 1. So 6 minus 6 plus 1, you get negative 1. So in other words, this oxygen will carry a negative formal charge, and this oxygen will also carry a formal charge in here. Okay. So the real way of how to draw the Lewis diagram for the carbonate ion should be like this. Okay. Okay. Then let's go for the next one, which is cyanide ion. So cyanide valence electron is 4. So you have 2 lone pair electrons in here. Okay. So you have 1 bonding pair electron and triple bond in here. So you have 2 unshared electron as I circle it. Okay, and then you have triple bonds in here, which is here, this one. So you have half times 6 here, 6 bonding electron. So you get 2 plus 3. So 4 minus 5, you get negative 1. So this carbon will hold a charge of negative 1 in here. Okay. So as for nitrogen, valence electron is 5. Okay, so you have one unshared electron, therefore 2 plus 6 of the unshared electron, therefore half times 6. So 2 plus 3 equals to 0. 5 minus 2 plus 3 equals to 0. So the formal charge in the negative here belongs to carbon, and this is the way of how you should draw cyanide ion. Okay. Now, as for nitrogen, so nitrogen you have starting from the center atom here. So valence electron of nitrogen is 5 minus, is there any unbonded electron? No. So 0 plus how many sharing electron? You have 8 in here. So therefore half times 8, which is equal to 4. So 5 minus 4 will give you a positive 1. So you have plus 1 in this nitrogen. Whereas similar to the calculation of the oxygen just now, so for the oxygen in the double bond, okay, so you have a formal charge equals to 0. And then for the formal charge of the oxygen single bond in here, you have negative 1. So the correct Lewis diagram for the nitrate ion will be drawn like this. Okay, so you have N plus O single bond negative negative, and then double bond O, and you have see that there is this structure like this. Okay, so we call it as a dative bond. So what is a dative bond? We will continue later on the parts. Okay, all right. So last but not least for sulfate ion. So for sulfate ions, okay, so sulfur, okay, let's start from the formal charge of sulfur. So sulfur, you have 6 minus 0 plus half times 8. So you have 2 plus 2 of this one. And then for the oxygen single bond, as we already calculated previously, all oxygen single bond will carries a negative charge here. So for such structure inside a covalent bond, it is abnormal because a covalent bond are supposed to have shared electron, not electron with charge in here. So, in other words, this sulfate ions is considerably unstable. So, the correct Lewis structure for the sulfate would be like this. So, when you have S double bond O, so that if you look heavily at the center atom of the sulfur in here, so sulfur is equals to 6 minus 0 plus half times 12. So you have 12 bonding pair here. So you have 6. Therefore, forward charge is equals to 0. And then for the oxygen double bond, as we already calculated, so this one will have a formal charge equals to 0 in here. And then O single bond will have the formal charge of negative 1 here. Okay, so therefore, the real Lewis structure for the sulfate ion is the most stable if you were to present your sulfate ion as like this, SO4 2 minus here, like this. Okay, so this is how you are going to draw for the correct Lewis diagram for the sulfate ions here, right? Okay, so other than these few examples of the molecular ion, we also have two more as exemplified. So let's see for the chlorate. So for chlorate, if you use the 4-step, okay, so eventually you get your chlorate looking like this. Okay, so this is chlorate ClO4 minus. Okay, and then you have phosphate. So the phosphate PO4 3 minus. So you have your phosphate ions looking like this. Okay. Okay, so to understand in which atom inside the molecule that possess the charge, the formal charge will be used accordingly. So in other words, nowadays students, we are going to stress a lot in the formal charge. So you should know on how to calculate the formal charge in the molecule in here. Okay. All right. So with that, that is all for the lessons in section 3. So I'll see you in our next video session. Thank you very much.